Okay, that one. Let's start looking at this. So again, this is a question designed by the writers of SAT, PSAT. Yep. So how did you approach this? How did you guys approach this one? Or did we just stare at it blankly until I started talking? If you want to sit here, Logan, you can. If you want to sit back there, you can. Or if you want to find an open spot somewhere else, you can. Okay.
Sure.
Okay. So with problems like this, you could just kind of give yourself a sketch, and that'll be enough to see what's going on with these two inequalities. So I'm just going to kind of graph them. I'm not even going to be super specific. I'm not going to use a proper graph up here or anything like that. You could just do this with testing points, but kind of doing a sketch will give you a more reliable way to get the vibe of it. So on this one, I know we start this one out by starting at a positive 1 and moving with a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, like this. So if I graph this, my line would look like this. And would I shade above my line or below my line? Yeah, it's going to be above. If you think about 0, 0, 0 and 2 times 0 plus 1, that definitely does not work. So we are going to shade this one above. So even just looking at this first one, I could probably answer the question. Because which of these sections has no solutions even to this equation? Quadrant 4. So let's see if doing the other line changes our opinion on this one. Let's see if there's more than one section, see if we got anything going off. So on this one, we would have starting at negative 1. We're going to go up 1 over 2, up 1 over 2, like this. So it's going to be kind of vaguely like this one. Nope, it's going to be a dotted line now. I am so good at lines, y'all. Ooh, it's so pretty. Look at that. Totally, perfectly straight freehand line. Not an art critic, never will be. So are we going to shade above or below this line? Above. Again, think about substituting in 0, 0. 0 greater than 1/2 times 0 minus 1. 0 is, in fact, greater than negative 1. So that's this guy here. So we can see our system, the place where we have both colors shaded, that's here. In this space, where it's got both colors. So I have points in this first quadrant in my solution set. I have points in the second quadrant in my solution set. And I have points in the third quadrant in my solution set. So I know this guy right here, quadrant 4, doesn't have any points in the system. We did tell that off of the first equation, but it's a good idea to kind of finish it out and look and make sure that other line doesn't point wrenches in that, especially if there's more than one option. Questions on this one? Okay. we have one last piece in this chapter. The very last piece. We're going to work on it today and tomorrow. And some of you have done problems like it, especially when we look at the challenge problem. Those of you that do the challenge problem available every week for extra credit, you've done at least one like this. Because what we're going to do today is we're going to talk about systems with more than 2 variables. So we're going to do 3 variables. And those of you that did last week's challenge problem, I'm sorry. Everybody who tried it got the points because that was worse than I anticipated. That's called I get them from online sometimes, and that one was mean. So systems in 3 variables, we're going to have most frequently an X, a Y, and a Z. But you'll see this pop up, honestly, a lot of times on Facebook. Those of you that have Facebook, it winds up in those emoji math problems where they'll have like French fry plus burger equals milkshake. And then 2 French fries minus burger equals 2 milkshakes. Those things. What does milkshake plus burger equal? That's looking at a 3 variable system. There were 3 little emojis there. So we can do this using the tools we have. We are not going to use graphing on this because if there's 3 variables, that's 3 dimensions. We're not graphing that. Ew. But we can use any of our algebraic methods for this. So inequalities, we only solve by graphing. 3 variable systems, we only solve algebraically. So when we are solving systems in 3 variables, I gave myself exactly 0 space to write. We are going to use substitution, elimination, or both. When we solve 2 variable systems, our answer is an ordered pair. That's when we would have our X, comma, Y. For our 3 variable systems, our answer is going to be something called an ordered triple, which is X, comma, Y, comma, Z. Alphabetical order. When in doubt, remember that. They go in alphabetical order. So just like when we have our systems and I need my answer to be an ordered pair. If I have a numerical answer, I need both X and Y. With our 3 variable systems, if there's an answer, I need all 3 pieces, X, Y, and Z. So this is our first 3 variable system. So you need to write all 3 of these equations down. We have 4x plus y plus 6z equals 12. And we have our 2x minus 10y minus 2z equals 12. And we have 3x plus 8y plus 19z equals 38. When we have 3 variable systems, or in fact, I believe all systems of any number of variables, you will have as many equations as you have variables. If I just gave us 2 equations with the 3 variables, we would not have enough information to be able to solve it. So that means we're going to have to do a lot of things to get things to combine. So in order for us to be able to talk about these, I actually have a tendency to give them names. So I'm going to call this top one A. I'm going to call the second one B. And I'm going to call the third one C. Just so it's easier to talk about than me saying the third equation and the second equation. Because what we need to do is we need to take these 3 equations and we're going to do 2 things to combine them. So I'm going to make pairs of equations, and we are going to eliminate one variable out of both pairs of equations. So I'm going to choose one variable that has no coefficient. So I'm going to eliminate out the y's on the first go through of this. I'm going to do a lot of this without necessarily having you guys make the choices on here, just so I can kind of show us the way to do this, because it's kind of weird. So I'm going to use the y's to eliminate out first, mostly because I have in here, I highlighted this being a jerk, a y that has no coefficient. That makes it very easy to get y's to eliminate out, because I'm going to take my b equation, which is my 2x, thanks Chris, minus 10y minus 2z, thank you. Thank you. Minus 10y minus 2z equals 12. And I'm going to use my a, but I want my y's to cancel out, so I'm going to take my a equation, but times 10, so that I have that same coefficient opposite side. I'm going to write that better because that's trash. A times 10. There we go. So if I take all of a and multiply it by 10, we are going to have 40x plus 10y plus 60z equals 120. So I've taken my a equation and my b equation, and I've made those y variables match, and so that pair of equations I'm going to add together using elimination. So I've got my 2x plus 40x giving us 42x. My minus 10y plus 10y gives me 0 y's. They eliminate out. That was kind of the point in picking that. And then I have my minus 2z plus 60z, and we get plus 58z. And that's going to equal 132. So I used my a equation and my b equation, and I got this. Questions on what I did in any of the pieces there? So I've used A and I've used B. Now I need to use C somehow because that hasn't been involved. So what I'm going to do is I'm going to make another pair of equations. I need to for sure use C. I'm going to come down here with that. We're going to have our 3x plus 8y plus 19z equals 38. I'm just bringing that one down. And then I need to eliminate the y's out in this pair as well. So I'm going to use my same a equation. I'm just going to multiply it differently. So what would I need to multiply a by to get my y's to eliminate out here? -8. I need them to have the same number with that opposite sign. So we're going to have our a times -8. That 8 looks weird, but you know what? I'm going to take it. So we're going to wind up with minus 32x minus 8y minus 48z equals -96. And then we do the same thing. I'm going to add the two equations together. When we do that, I'm going to get minus 29x minus 29z, because the y's eliminate out, and that's going to equal minus 58. Now what we have is I have two leftover equations. Okay, let me take a pause right there. Questions on what I did in either of those two steps? I know we don't really know why yet, but questions in those two steps? Oh, they're in the back by the flag. How did I get which piece? Oh, I was trying to get the y's to eliminate out up here. Yeah, I was eliminating out my y's. And I eliminated the same variable down here. It's very important we get the same variable out. Because now what we have left over, I have 42x plus 58z equals 132. And I have this equation here, the negative 29x minus 29z equals negative 58. And this is just another system now. So these are the systems that we gave you last week. This is a two-variable system. So we're going to solve this just like we did that. We could do it substitution. We could do it elimination. If we go for z's, it's going to be the easiest math. Let's go for z's because 29 times 2 is actually 58. That's okay. Oftentimes in these systems, you should get decent numbers. If you are winding up with fractions and grossness every single time, stop and check in. So I'm going to multiply the pink one by 2. So I'm going to have my 42x plus 58z equals 132. I'm not changing. I'm going to take this guy times 2 and put it underneath. We're going to get minus 58x minus 58z equals minus 116. And then we can add those together. So we're doing 3 sets of elimination so far in this problem. (42x minus 58x gives me negative 16x. 58z minus 58z, those cancel out. And we're going to equal 132 minus 116, which is 16. Yep. So we get x equals negative 1. Whew, we've got an answer. Now we're going to have to go backwards and substitute pieces in to find our y's and our z's. What's up? What's up? Where'd I lose you? I know sometimes all we got to do is ask out loud to find it, but let me know if I can help.
This is so much work.
It is a lot. There's a lot.
Who even does
Would there be less questions today?
What's up?
Is there always going to be 3 equations with 3?
Yes. If you have 3 variables, you need to have 3 equations, which means you're going to need to do 3 things.
Say no.
I was like, notice on the homework, there are, I believe, 3. End of sentence. Like,
It's okay.
might be 2, but
The math is too much math.
it's a lot. That's why there's not tons. So to find our other pieces, I'm going to go find any of these equations that have an x and only one other variable. So I'm going to use red or pink. It genuinely doesn't matter. We could use any of them. Either of them is fine. I do not recommend going back all the way up to the beginning, or then you get to do the whole solving systems again, because we would need to know two variables. So use the red or the pink.
I think we should use the easier one.
Neither one of them is awful.
That's not helpful.
I'll use red just because it's on the top. What's up? No, we did not have calculators at that point. Sorry, keeping it even for you and everybody else.
Yeah, I forgot about that. I forgot it was on work.
Yeah, it's okay. All right, so I'm going to take, what's up?
Is logic 0?
Y is not 0. So I'm going to take my 42 times the negative 1, taking my 42x, plus 58z equals 132. So I have negative 42 plus 58z. So if I add 42 to both sides, I'm going to have 58z equals 174. Z is 3. Z is 3. So now we pick any equation to go back and find y. A doesn't have any coefficients for y, so that makes it easier. So I'm going to grab A, and we're going to substitute my x and my z in so we can find the y. So we're going to have 4 times my x, which is negative 1, plus y, plus 6 times my z, which is 3, equals 12. So we have negative 4 plus y plus 18 equals 12. So get to my y. What does y equal?
Negative 2.
Yes.
Yay.
Sorry, I was just confirming before I said yes.
18 plus 4.
No. Yes, and then you have to subtract on both sides.
Mhm.
Okay, so we're saying no.
Yeah. Yeah. No, you did fine. You're doing fine. I was just thinking through what you were saying, combining together the minus 4 and the 18. So we have y plus 14 equals 12.
Yeah.
Subtract 14 on both sides. Y equals negative 2. So remember, ordered triple. We wrote that on the last page. So x, y, z, alphabetical order. Negative 1, comma, negative 2, comma, 3.
It's in numerical order.
It is indeed in numerical order, but more importantly, it's in alphabetical order. X, Y, Z. Just like we normally have X, Y, since we have a Z, X, Y, Z.
So, where do I ever use this in real life?
Just for one problem.
So this is used in navigation, honestly, a lot. That would be where we would have three-dimensional travel, because that's really what this is. This is length, width, height. This is dimensions on boxes. This is on shipping containers and how they fit. This is fitting products into boxes. This is I sell shoes, belts, and scarves. So these do happen. They're not usually like a super common thing we have real life. Most frequently where you see them is in emoji math problems on, can you do this? Are you smarter than a fifth grader? Like that kind of stuff. Where old people fight about order of operations on Facebook. those kind of things is where, honestly, where we see them a lot. But again, just as a reminder, high school math isn't necessarily about can you do these math operations. It's can we persevere and stretch the muscles in our brain.
Not necessarily.
Because these are hard. Yeah, I mean, the state sets what you have to learn, and this is definitely included in there. We double check every year. But it's one of those things that it's not necessarily about the calculations themselves. It's stretching the muscles in your brain. The more times we practice and practice learning and practice going through hard things, the better we are at doing that when it comes to like our job and something we don't like to do at our job and still have to do. All right, we're gonna do one more.
I'm gonna flip to the next page. These take the whole class period.
I don't even have like a third one available. Like, so this is the last one for today, for sure.
I'm excited. The SpongeBob Spirit for the cast and crew and pit came in last Friday.
Nice.
So hopefully I'll get it tonight. I don't know.
To be, y'all should do Safe Trick or Treat in costume. That would be epic.
They're legit thinking, they talked about earlier in the year, making crew wear costumes too. And I'm like, oh, yeah.
That would not be the first show that does that. I'm not talking here, but there are shows where crew does dress because crew's seen.
Like what?
It happens in things like Avenue Q. The crew is part of the cast every now and then. Very rarely, but it happens.
We could have done that for the Wiz because there was multiple times where I had to be on stage for the Wiz and you could still see me. Right.
All right, so here's our three equations. I'm going to call A my 3x minus 18y plus 6z equals 7. I'm going to have B be my 7x minus 2y plus z equals 1. I'm going to have C be minus x plus 6y minus 2z equals negative 2. So I'm going to go with eliminating out my x's. Because I have an x that just has a minus sign in front, so I'll be able to multiply that to get it to eliminate out with the 3 and the 7 very easily. You could also do the z. That one is set up quite nicely. I could go times negative 6 and times positive 2. I could even do the 2y to make 6y and 18y. So I can use any one of them, but I'm going to go with the minus x. I feel like that one's going to be set up easiest. So I'm going to take my B and C first of all. So I'm going to use equation B. That's my 7x minus 2y plus z equals 1. And I'm going to take my C times what?
7.
Times 7. It's already got the minus sign, so I don't need to do minus 7. I got it.
I visibly jumped.
It's okay. It says not like you made it. That's kind of the point. I know. That's what I thought. It's all for me. I'll take it. Thank you. Pencils.
Ooh, yay.
It was a present pencil delivery. I got visited by Pencil Fairy. All right, so we're going to multiply our C equation by 7. There we go. Put those out.
Oh my god.
So it's going to give us our minus 7x plus 56y, ew, minus 14z. Oh, not 56. Sorry, that's called, I did these at home And my brain was tired. 42.
Oh. Isn't it like 42?
It is 42. Yeah, no, 100%. Call me and stuff. Yeah. You guys are right. You guys are right. 42. Not 56. 42. 14. Okay, there we go. It is 42. I mean, I definitely did it on purpose. Make sure we were paying attention. Totally, 100%. Yeah. No, it's good practice for us to be able to spot when mistakes are made. It happens. That's exactly why you guys show work. Because if that happens and all your work is right, we lose maybe 1 point. Maybe. Like a half point sometimes. If all the work is right and we've made one tiny arithmetic error, it is not that we get the whole question wrong. It's that I figure out where something went wrong and take off points accordingly to that. So we combine those together and we're going to get my 7x minus 7x cancels out. We get 40y minus 13z equals negative 13.
Oh, that's what I messed up on. Okay. I got it. Somebody told me Ian was cute today.
All right.
I'm confused on the A and C. Because I think that one's about 83, you think that one, and it cancels out too.
There's a reason. I did B and C first. All right, so let's look at A, because we haven't used that one. We need to. And I want to eliminate out the same variable. I want to eliminate out my x's. So if I need to take my 3x minus 18y plus 6z equals 7, and I need to eliminate out my x's, what do I need to multiply my c by? C times 3. So we're going to have our minus 3x plus 18y minus 6z equals minus 6. So, what's up? The negative 2 from, this minus 2, we did times the 3. The whole equation times the 3. So when we add them all together, my 3x plus negative 3x, those cancel out. Negative 18y plus 18y, those cancel out. 0 equals 1.
It makes no sense.
You're right. It makes no sense. Because does 0 equal 1?
No.
Ever?
No.
Never, ever, ever? So where might we have a solution?
Nowhere.
Nowhere. This has no solution. Because all my variables canceled out, and I wound up with a statement that is false. So no solution. So if I wind up with no letters, all my letters canceled out, and I wind up with something that's false like this, it means there's no solution. This is false. So there is no solution.
Equation is false.
Because what these two equations are, A and C, are parallel lines. They do not cross, even in a three-dimensional space like this. They do not cross at all.
We're done. Yay.
We are. So homework 7, the one that's up there with the bell work page, is the last homework of the chapter. Our chapter test is Friday. We have PSAT on Thursday, so we're going to have like review day together where we work together on review on Wednesday. Tomorrow, we're just gonna work another couple of these.
On what, Thursday?
So they're not, these don't get worse, is what I'm trying to say is. These equations do not get worse. We're just gonna practice a couple more times tomorrow. So you could do everything on homework 7.
No, I wasn't freshman year.
What's up?
Let me come down and finish this.
Do you want to do just tomorrow on the same time? Oh, what you mean? Yeah.
Okay, thank you.
Yeah, yeah, no worries.
Farley, but Farley said no, we didn't.
Yes, we did. We
Maybe
took,
freshman year.
the juniors took PSAT freshman year.
Yes, we did.
And then after we became sophomore, yes, we did.
That's what I said.
Freshmen don't take this.
That's what
No,
I said.
they.
There was 1 year. There was 1 year that the
Our
juniors.
year
It
that we
was all
did.
year. Told y'all.
That's why I said I'm not coming on Thursday. I already took
But
it.
I'm taking it one more time. They-
I was gonna say it's how you get things like scholarships.
Yeah.
They offer scholarships through PSAT and PSAT scores.
I didn't good on my
I did, I'm gonna say I did good.
Yeah, wait, how did you find out your PSAT scores?
I think. Well, back in my day, they mailed them to you.
Oh.
We have an app for that now.
Yeah. To be fair, we didn't have apps. We barely had texting.
I don't even remember what my PSAT score was.
Yeah, I was gonna say if you would imagine texting, there were letters on the number keys. These 10 buttons. Oh, hang on, I'm gonna pull it up.
So I could never last back in the day. Yes, that's why y'all so smart. We got a calculator for everything.
No, look.
All right.